Okay, so we are working on differentiation. This is the paper one. We are working on the course book. So this is the lecture number 2 on the differentiation exercise. And the book we are using is this book. This is the book which we are using, and so these are the questions today we are going to attempt. So we are starting question from the question number 10. Total there are 19 questions. So I'm going to attempt the question number 10. He says find the coordinates of the points on the curve y is equals to x cube minus 3x minus 8 where the gradient is 9. Okay. So see, they have given you the equation of the curve. The equation of the curve is y is equals to x cube minus 3x minus 8, and we have to find the coordinates of that point where the gradient is given. The gradient is 9. So we have to find the points where the gradient is 9. So the method is very simple. What we will do, we will derivate it, and once we have derivated it, we will make that derivative equals to 9 because the derivative represents the gradient. So you have y is equals to x cube minus 3x minus 8. I will derivate both the sides. So dy by dx will be equals to 3 will come on the side. Power will be decreased by 1. Minus 3x derivative is 3 and minus 8 derivative is 0. So the dy by the dx will be equals to 3x cube minus 3. And because they have told us that the gradient is 9, so I will make this derivative equals to 9. So this thing 3x cube minus 3, we will make it equals to 9, and from there I can find the value of the x. So this will become 3x cube equals to 9 plus 3. So 3x cube will be equals to 12. So the x cube will be equals to 12 divided by 3. Okay. So, sorry, this is not x cube, this is x square. Oh, by mistake, I wrote x. This is x square. Sorry. This is x square. So, the x square will be equals to 4. Take the square root on both the sides. So, you will have x square equals to 2. X will be equals to 2. And it will be plus minus 2. Okay. When you take the under root, you so you see now find the value of the y also. These are 2 points on which the gradient of this curve is 9. There are 2 values of x. One is positive 2 and the other one is minus 2. So what I will do, I will substitute this value of the x in the original equation and we will find what is the value of the y. So you see y, when the x is positive 2, y will be equals to 2 cube minus 3 into 2 and minus 8. So it will become 8 minus 6 minus 8. So this is minus 6. So the coordinates of that point will become 2 comma minus 6. This is one of the points. The other point we can also find. We can substitute the value of the x as minus 2 in the original equation, and I can find the value of the y. So let me do this here. So y will be equals to minus 2 cube, and then we have minus 3 into minus 2, and then you have minus 8. The y will be equals to, this will be minus 8, it will be plus 6, this will be minus 8, and the y will be equals to minus 16 plus 6. So you left with the minus 10. So the gradient, the point will be minus 2 and minus 10. So you see there are 2 points in that curve where the gradient of that curve is 9. So let me check the answer. So minus 2 comma minus 10 and 2 comma minus 6. So our answers are right. So this is from the exercise 7a, and we are on the question number 10. We have completed the question number 10. From question number 2 to question number 9, I did it yesterday. So this is, I hope you understand. Soon I will upload this video. This is live video, but I will also upload this video on my later. Means you will be able to find the recording of this video as well. Okay, so now we are moving to the next question. That is question number 11. It says find the gradient of the curve, and the equation of the curve is given. That is y is equals to 5x minus 10 divided by the x square. So find the gradient of the curve whose equation is y is equals to 5x minus x square at the point where the curve x-axis. So he says when curve crosses x-axis. You see, whenever the curve will cross x-axis, at that point we have to find out the value of the gradient. Okay, whenever the curve crosses the x-axis, the y will be 0. So what I will do, I will put y equals to 0. So 0 is equals to 5x minus 10 divided by x square. So this x square will come here, it will become 0. So 5x minus 10. So 5x will be equals to 10. X will be equals to 10 by 5. X will be equals to 2. So the point when that curve crosses the x-axis is 2 comma 0. This is that point. So we have to find out the gradient at this point. So if you want to find the gradient at this point of that curve, so what you will do, you will derivate it, and then in that derivate, you will in the place of x substitute 2. And you will be able to find out the value of that. So let me clear this. So we will derivate this. Y is equals to 5. So I will separate it. I will try to simplify it. This is x square minus 10. Okay. So you see, I'm simplifying it before I derivate it. So this will become y is equals to 5 x raised to power minus 1 minus 10 into x raised to power minus 2. Now I can derivate it easily. So this will be dy by dx. 5, the power will come on the side, the power will decrease by 1. So 10 into minus 2, and the power will decrease by 1. So you see, this is how you derivate it. So this will become minus 5 divided by the x square. This will become plus 20 divided by the x cube. So this is the value of the dy by dx. Now I want to find the gradient at this point where the value of the x is 2. So put x equals to 2. X equals to 2 in this equation. So you will have dy by dx equals to minus 5 divided by 2. It's square plus 20 divided by 2 and its cube. So this will be minus 5 by 4 plus 20 by 8. So when you take its LCM, it will be 8. 8 will be the LCM. So 2 minus 10 plus 20. So it will be something like 10 by 8. So the gradient is 5 by 4. So I think the gradient is 5 by 4. Let me check the answer. If the answer is right, we have done 5 by 4. Question number 11, the answer is 5 by 4. Our answer is also the same. I hope you understand. A curve's equation was given. They say when it crosses the x-axis, when it crosses the x-axis, you put y equals to 0 in that equation and you get the value of the x. So the coordinate of that point when the curve crosses the x-axis is 2, 0. So then I derivate that equation of the curve, and in the after the expression which I got in the derivation, and the x is substituted with the 2, and we got the gradient of the curve at the point when it crosses the x-axis. So this is how you do the question number 11. Okay, so I hope you understand. So we are moving to the next question. That is question number 12. I have checked the answer from the book. You see in this live, we are doing actually these videos on the A levels. They are not for very bright people. They are for those people who are struggling with mathematics. So they need question by question guidance. Okay. So these are not for some brilliant, very brilliant people. So question number 12. Question number 12. He says the curve. Here, question number 12. Here, the equation of a curve is given. He says y is equals to x squared minus 4x and minus 5. So they say the curve y equals to x squared minus 4x minus 5, and the line y, there is a line, and the equation of the line is y is equals to 1 minus 3x. Meet at the point A and B. Find the coordinates of the point A and B. This is the A portion, and the B portion is find the gradient of the curve at each of the point A and B. Very simple. If you want to find out, this is the equation of a curve, this is the equation of a line. If you want to find out the point of intersections of these two, this curve and a line, you have to solve them simultaneously. So this is y equals this is y. So I'm going to make them equals to each other. So it will be x squared minus 4x minus 5 equals to 1 minus 3x. So it will be x squared minus 4x plus 3x minus 5 minus 1 equals to 0. This will become x squared, and it will become minus x minus 6 equals to 0. You see, you got this expression in x, and we can very easily do the midterm breaking. I hope you have learned the factorization. So this will become x squared minus 3x plus 2x minus 6 equals to 0. So x into x minus 3 plus 2 into x minus 3 equals to 0. So this will become x minus 3, x plus 2 equals to 0. So one x value is 3. The other x value will be minus 2. Now we can find the value of the y as well, because in the A part we have to find out the coordinates of the point of intersection. So I can find what is the value of the y here. So y will be equals to 1 minus 3 into 3, and the y will be equals to 1 minus 9. It will be minus 8. So that is 3 comma minus 8. Same way I can find the value of the y here, 1 minus 3. I'm substituting the values in this equation. So minus 2. So this will be equals to plus 6, and 1 plus 6, that is 7. So the coordinates of the point where, so let me call this A point, let me call this B point. So these are the 2 points where the curve and that line is intersecting. The A part's answer on the book are minus 2 comma 7 and 3 comma minus 8. And this is the A part of the question number 12, where we have to find out the point of intersection between this line and this curve. Now let's go to the B part. He says find, in the B part of question number 12, he says find the gradient of the curve at the point at each of the points A and B. So if you want to find out the gradient, so what you have to do, you have to derivate that curve. So that curve square minus 4x minus 5. So you see, very easily we can derivate it. So dy by dx will be equals to, this power will come on the side, the power will be decreased by 1. So you can see this is how you will derivate this. So the dy by dx will be equals to 2x minus 4. So when x is equals to 3, so the gradient will be equals to 2 into 3 minus 4, that is 6 minus 4, and that is 2. And when the value of the x is equals to minus 2, then the dy by dx value will be 2 into minus 2 minus 4, that's minus 4 minus 4, that's minus 8. So this is the B part of the question number 12. And you have to find the gradient of the curve at the point A, and you have to find out the gradient of the curve at the point B. So let me check it. The book says that it will be 2. This is question number 12, minus 8 and 2. It's positive 2. Sorry, this is positive. Sorry, that's good. So at one point the gradient will be positive 2, and at the other point the gradient will be minus 8. So this is how you do the question number 12. I hope it's clear. Okay, so let's go to the next question. Find the gradient of the curve. Okay, let me erase this so I can write it. Okay, so here we have question number 13. It says find the gradient of the curve. This is question number 13. The curve is given y is equals to x cube plus ax square plus bx plus 7. He says the gradient of the curve y is equals to x cube plus ax square plus bx plus 7 at the point 1 comma 5. Here a point is given. At the point 1 comma 5, the gradient is the dy by dx answer is minus 5. So their question is, what is the value of the a, what is the value of the b? You see here equation of a curve is given x cube plus ax square plus bx plus 7. At the point 1 comma 5, the gradient of the curve is minus 5. They want me to find out the value of the a and the b. Okay, so first of all, what we will do, we will find the derivative of this, and the y is equals to x cube plus ax square plus bx plus 7. Here are two variables which we want to find out, a and b. Okay, means they are unknown, they are not variables actually. So what I will do, I will take the derivative, and it will become 3x square plus 2ax plus b plus 0. They have told us that the derivative is minus 5 when the x value is 1. When x is equals to 1, the derivative, which is the gradient, is minus 5, you can say. So I should write dy by dx, okay? So you will have 3 into 1 square plus 2 into a into 1 plus b is equal to 3 plus 2a plus b equals to minus 5. So you will have 2a plus b equals to, this will go there, minus a. So this is my one equation in a and b. Okay. So this point, which is on that curve, also satisfies that. So it means if I put in the place of x, I put 1, and in the place of y, I put 5. So they will satisfy this equation. So in the place of y, I will put 5, and in the place of x, I will put 1. Because there are two unknowns, so I need two equations. Oh, sorry, I have to put 1 here. The x value is 1 plus 7. So it's 5 equals to 1 plus a plus b plus 7. This is 8. It will go on the other side. It will subtract. 5 minus 8 will be minus 3. So this is my second equation. So now you see there are two unknowns, A and B, and we have already formed two equations in A and B. So we can solve them simultaneously. It's very simple. So let me make space here. Okay. So I can solve these two equations simultaneously. So what I'm going to do, 2a plus b equals to minus 8, a plus b equals to minus 3. Simply take this as first equation, take this as second equation, and simply subtract them. From the left side, subtract the left side. From the right side, subtract the right side. So you will have 2a plus b minus bracket start a plus b equals to minus 8 minus 3. So you see, I'm solving them simultaneously. So because both of them, the b has the same coefficient in them, both coefficients are positive of the b. So what I will do, I will simply subtract from the first equation the second equation. From the first equation, subtract the second equation. From the left side, you subtract the left side. From the right side, you subtract the right side. So you will have 2a plus b minus a minus b equals to, this will become a minus 8 plus 3, that's minus 5. And minus b gone, this is a is equals to minus 5. So I got the value of the a. I can put that a value back into any of the equations. For example, 2a plus b is equals to minus 8. So in the place of a, I will write minus 5 plus b equals to minus 8. So minus 10 plus b equals to minus 8. So b will be equals to minus 8 and plus 10. So b will be equals to 2. So the value of the a is minus 5 and the value of the b is minus there is some, a value is 2 and the b value is minus 7. Made some mistake. We are doing question number 13. He says the value of the a is 2 and the value of the b is minus 7. That's question number 13. So I made some mistake here. So what mistake we did? Let me check it. Let me check it again, okay? So question number 13, the point was, I made a so 1,5, the gradient is 5. The mistake is that I wrote there question number 13, but I solved actually question number 14. Question number 14 is minus 5 and 2. By mistake, what happened, instead of solving question number 13, I did question number 14. You see, we are going live, so there is possibility that I might make a mistake. This is question number 14. So after doing this, we can go to the question number 13. So this is the question number 14 and the answers are good. So after this, we can do the question number 13. Okay, so let's do the question number 13. By mistake, I did question number 14 first. So hopefully this is clear to you. And you see, we are doing these questions for those students who are weak in mathematics and they need a lot of help. So maybe these videos might be helpful for them. Okay, so let's do question number 13. Okay. The gradient of the curve y is equals to, here a curve is given. He says y is equals to ax square plus bx. At the point is given 3 comma minus 3. The gradient is 5. The dy by the dx value is 5. So let me check again. This is question number 13. The gradient of the curve y equals to ax square plus bx at the point 3 comma minus 3 is 5. Find the value of the a and the value of the b. Okay, so we have to find out what is the value of the a, what is the value of the b. So you see, it's very simple. So I know the point, I know the derivatives, answer, the value, I mean, at this point. So I will take the derivative. So first of all, let me write y is equals to ax square plus bx. So dy by dx will be equals to 2ax plus b. So at x equals to 3, the derivative's value will be equals to 5. So you will have 2 into a, the x value is 3 plus b is equals to 5. So you will have 6a plus b equals to 5. So this is my first equation. Okay, in the AB, this is my first equation. Then because this point is on this curve, so in the equation of that curve, in the place of x, you can put 3, and in the place of y, you can put minus 3. So what we will do, we will take that equation of the curve, and that is y is equals to ax square plus bx. So in the place of x, I will put 3, and in the place of y, I will put minus 3. So this is 3 square plus b into 3. So this is minus 3 equals to 9a plus 3b. Divide all of them with the 3. You got minus 1 equals to 3a plus b. So your equation is 3a plus b is equals to minus 1. So this is my second equation, and this is my first equation. Now you see, I have two unknown. One is a, the other one is b. And if you have two unknowns, to solve them, we need two equations. So what we will do, we will solve these two equations simultaneously. So you have here 6a plus b equals to 5, and the other equation is 3a plus b equals to minus 1. So what simply you do, from the first equation, subtract the second equation, the b will be eliminated, and you will get the a answer. So 6a plus b, and you have to subtract minus 3a plus b is equals to 5 minus minus 1. So from the first equation, I'm subtracting the second equation. So you will have 6a plus b minus 3a minus b equals to 5 plus 1. That's 6. So b be gone. This is 3a equals to 6. A will be equals to 6 divided by 3. So the a will be equals to 2. So this is how you will find the value of the a. Then you can substitute this value of the a in the first equation, and you can find the value of the b. So 6 into 2 plus b is equals to 5. So the b will be 5 minus 12. So b will be equals to minus 7. So the a value will be 2. The b value will be minus 7. Let me check from the book. The answer, question number 13, the a will be 2 and the b will be minus 7. So this is how we will do question number 13. Okay, so we are going to the next question, and that is question number 14 we have already done. And now we are going to the next question, that is question number 15. So question number 15. It says that here an equation of a curve is given. The equation of a curve is given. So he says, question number 15, we are talking about the question number 15. He says the curve y is equals to, here we have an equation y is equals to ax plus b divided by the x square, has a gradient of 16. is gradient. Gradient is represented with dy by dx, or sometimes you can say m is equals to 16 when x is equals to 1 and the gradient is -8 when x is equals to -1. Find the value of the a and the b. Okay, so you see this is the question. Let me read it again. This is question number 15. He says the curve y is equals to ax plus b divided by x square has a gradient of 16 when x is equals to 1 and the gradient -8 when x is equals to -1. Find the value of A and the value of the B. So if you want to find out the value of the A and the value of the B, very simple. You have to derivate this thing, y, the equation, y is equal to ax plus this will be bx raised to power minus to bring this x square upstairs. Now you can derivate it. So the dy by dx, that is equals to a plus b, and this -2 will come on the side. The power will be decreased by 1, so this will become -3. So this will become a minus 2b divided by the x cube. Okay, so this is how you will find the expression for the dy by dx. So they say when the x is equals to 1, the value of the dy by dx is 8. When x is equals to 1, the a minus 2b divided by 1 cube, that is equals to 16. Okay, so this is a minus 2b is equals to 16. So this is my very first equation. Then they say when x is equals to -1, the derivatives value will be -1 and its cube is equals to -8. So this will become a -1 cube is -1, so minus this will become positive. So 2b is equals to -8. So this is my second, and this is the second equation. So we can solve them very easily. If you look at these equations, a minus 2b is equals to 16, a plus 2b is equals to -8. So these are two equations in a and b, and very easily we can find the value of the a and the b. Okay, so let me. So you see, what we will do, we will simply add these two equations. So a minus 2b plus a plus 2b is equals to 16 plus -8. Okay. So in the left side is added. In the right side is added. So 2b, they will be cancelled. So you will have 2a equals to 8. So a will be equals to 8 divided by 2, and that is equals to 4. Now I got the value of the a, that is 4. I can substitute in the first equation, which is here. So 4 minus 2b will be equals to 16. So minus 2b, this 4 will go on the other side, subtract. And minus 2b is equals to 12. So b will be equals to 12 divided by -2. And the b will be equals to -6. So I think the a value is 4 and the b value is -6. Let's check if our answers are right. The a value is 4 and the b value is -6. So my dear students, this is how you will do the question number 15 of the exercise 7a, and this is paper 1 of the mathematics 9709. This is Cambridge A levels AS mathematics, the paper 1. So we are working on this the syllabus content derivation, and this is the very first topic, very first exercise of this topic. Okay, so I hope this is clear to you. Question number 15. Now we are going to the next question, that is question number 16. So Question number 16 is coming up. So here we have question number 16, and it says, given that the gradient of the curve y is equals to x cube, here the equation of a curve is given. He says y is equals to, sorry, x cube plus ax square plus bx plus 3. He says, given that the gradient of the curve y is equals to x cube plus ax square plus bx plus 3 is 0 when x is equals to 1. Its gradient is 0 when the x is equals to 1. And when the x is equals to 6. Okay, he says gradient is also 0 when the x is equals to 6. Then they say find the value of the a and of the b. Listen carefully. This is question number 16. He says, given that the gradient of the curve y is equals to x cube plus ax square plus bx plus 3 is 0 when x equals to 1 and when x is equals to 6. Find the value of a and the value of the b. Okay, so what we will do is very simple. We will derivate this curve's equation. So this is basically y is equals to x cube plus ax square plus bx plus 3. So it will be dy by the dx is equals to 3x square plus 2ax plus b plus 0. The derivation, and the dy by dx will be equals to uh, when they say it's 0, when x is equals to 1, they say the derivative will be equals to 0. Okay, when the x is equals to 1, the derivative is 0. So what will happen? It will be 3 into 1 square plus 2a into 1 plus b is equals to 0. So this is 2a plus b equals to, this is minus, take this 3 to the other side. Okay, then they say when x is equals to 6, the derivative is again equals to 0. The derivative is again equals to 0. So 3 into 6 square plus 2a into 6 plus b equals to 0. So this will become 12a plus b equals to 6 square is 36, and 36 threes are 3, 18, 1 3s are 9, 108. So 12a plus b, 12a plus b is equals to 108, and the other equation is 2ab equals to minus 3. So we can solve them simultaneously very easily. The b and the b, they have the same coefficient, so simply subtract them and you will be able to find their 3 3s are 9, 9 and 1. 3 6 are 18. I think it's right. I'm not using calculator. So okay. So what we will do, we will, okay. So you see, I can solve these simultaneous equations. So simply you have to subtract them. 2a plus b. From here you subtract, from the left side you subtract the left side. 12a minus b is equals to minus 3 minus 108. Okay, I hope I have not made any mistake. So 2a plus b minus 12a plus b is equals to, this will become minus 1 1 1. Okay, you see. So oh, no. There was, this was plus b. Sorry, this was plus b. So this is minus b. So b and b will be cancelled. You are left with the minus 10a equals to minus 1 1 1. So A will be equals to 1, 1, 1 divided by 10. So let me check first of all. So this is 10.5, which is right. A is, but this is minus 10.5. This is A is minus 10.5. Something went wrong, I think. Uh, let me check. Question number 16 we are doing. To 1, the gradient is 0. Okay. So from, okay. So this is basically, when it came here, it is supposed to be negative. Okay. So I made some mistake. Mistake of a sign. Okay. This was negative. So this become minus 3 plus 108. So it will become 105, and it's positive. So this is minus A. So A will be equals to, this is 105. So it will be basically minus 10.5. Okay. Now it's right. I made a mistake. I did not put a negative sign here. Okay. You see, A levels maths is all about doing the procedure correctly. So the concept is very easy. You see, but when you work on the procedure, so there the weak students make mistakes. Okay, so A is equals to minus 10.5. So I will put that in anywhere. Let's say I take the first equation, 2 into A value minus 10.5, and then you have plus B equals to minus 3. Okay, so this will become 21. So this is minus 21 plus B is equals to minus 3. So B will be equals to minus 3 plus 21, and the B will be equals to 18. So the value of the B is 18, and the value of the A is minus 10.5. So you see, let's check the answers. Question number 16, A is minus 10.5. Our answer is also the same. And the B is 18. So our answers are right. This is how you do the question number 16 of the exercise 7A. This is the second lecture on this exercise. I'm following the Cambridge International AS and A level mathematics course book, Pure Mathematics 1. This book is related with the paper 1. This is AS mathematics. Okay. Question number 17. Question number 17. Though total there are 19 questions, so we are on the question number 17. So let's see. Okay, so question number, I'm going to work on question number 17. So, question number 17, he says, given that the y is equals to, this is question number 17. Here a curve is given. He says the y is equals to 2x cube minus 3x square minus 36x plus 5. This is the equation of the curve given. Given that the y is equals to 2x cube minus 3x square minus 36x plus 5. Find the range of values of the x. We have to find the range of values of the x. For which you see the dy by dx is less than 0. Okay, we have to find the range of values of the x for which the dy by dx will be less than 0. Okay, so let's start. Okay, so we will have here, this is that equation y is equals to 2x cube minus 3x square minus 36x plus 5. So we will derivate them. Dy by dx is equals to, this will become 2 into 3 into x square minus 3 into 2 into x raised to power 1 minus 36 plus 5. You see, this is how I will take the derivative, and the dy by dx will become, this becomes 6x square minus 6x and minus 36. Okay, they say, so this is the derivative, they say dy by dx is less than 0. Can you see this is a quadratic, this is a quadratic, okay? So uh, so let's find the it's so now I'm talking about only this thing, okay? So let me find out when this is equals to 0, okay? So divide everything with the 6, so we will have this. So this will be x square minus 3x plus 2x minus 6 equals to 0. So this will be x into x minus 3 plus 2 into x minus 3 equals to 0. So x minus 3 into x plus 2 equals to 0. So that means x equals to 3 and x is equals to minus 2. Okay. So these are the I am finding when the x when the this thing will be equal to 0. You see, it's a quadratic expression, and its x square is positive, and so that means it's a happy face. So it's something like this, and if this is my y equals to 0, so let me say this is y equals to 0. So let me say this, and y equal to 0 mean x-axis. So it, according to this solution, it will cut the x-axis at the point minus 2, when the x is minus 2, and when the x is equals to 3. So their question is when your graph is less than 0, when the dy by dx, this is the equation for that dy by dx. This is the graph for that dy by dx. You see, we are looking for this thing, dy by dx less than 0. Less than 0 means it's below than y equals to 0. So that portion is here. That portion is this one. Okay. So from here, I can tell you that this is the x value is ranging from minus 2 to 3. So when the x values are going from minus 3 to 3, the graph 6x squared minus 6x minus 36, that is in the negative portion of that value is negative. So the range is the x is greater than minus 2 and less than 3. So this is how you will do. I hope you have studied that chapter. I have not made video on that chapter. This is the second video on the A levels mathematics which I am making. So hopefully, if I get time, I will work on that chapter number 1 and chapter number 2 and 3. So that concept is taught there. Okay. So this is how you do the question number 17. Okay. Then we have a same kind of question number 18. And let me have this. So the question number 18 is also of the same type. So let me go there. Question number 18. So question number 18. He says question number 18 is given that y is equals to, this is question number 18. Y is equals to 4x cubed and plus 3x square minus 6x. Find the range of values of x. We have to find the range of values of x for which the dy by dx is greater than and equals to 0. You see, this is also again the same kind of question as the question number 17 was. So what we will do, we will derivate this and we will find the expression for the, so this is y is equals to 4x cube plus 3x square minus 6x minus 9. So I will take the derivative on the both the sides. So this will become 4 into 3 into x square plus 3 into 2 into x minus 6 minus 0. You see, I have taken the derivative. Then just simplify it further. dy by dx, this is 12x square plus 6x minus 6. So I will make this dy by dx equals to 0 to find out its point of intersection with the x-axis. Okay, so divide everything with the 6. You will be left with this. So this is square. So 2x square plus 2x minus x minus 1 equals to 0. Take 2x common, so x plus 1 minus 1 x plus 1 equals to 0. This is x plus 1 into 2x minus 1 equals to, make them equals to 0. So this will be x equals to minus 1 and this will be x equals to 1 by 2. Okay, so you see, if you look at this expression, this is 12x square plus 6x minus 6. Its x square is positive. Its coefficient is positive. So it's a happy face. So the graph will be something like this. And suppose this is that x-axis. The x-axis is y equals to 0. So according to this solution, will be intersecting the x-axis when the x is equals to minus 1 and when the x is equals to 1 by 2. So it will be cutting the, you see, at x equals to minus 1 and x equals to 1 by 2. So they are saying what we are looking for. We are looking for this. We are looking for this. When your dy by dx is equals to or greater than 0. So when it is greater than 0 in this portion, the graph of the dy by dx is positive, is more than 0. And in this portion, okay, so the range of the x should be less than or equals to minus 1, and the x should be greater than and equals to 1 by 2. So in this portion, the graph is positive as value equals to 0 or more than 0. And in this portion, the graph is above the y equals to 0. This was what we were looking for. So let's check what's the answer. And in the book, it says x is less than or equals to minus 1 and the x is greater than 1 by 2. Okay, so we are done with the question number 18. And now we are going for the question number 19, which is the last question of this exercise. This exercise is exercise 7A from this book. We are using this book for your, paper 1. This is the course book for the paper 1, and this is the AS from this book. And after doing the work from this book, they prepare for past papers, and then they are good to go. So this is how we have done question number 18. The last question of this exercise is question number 19, and this is question number 19. Okay, it says that a curve has equation y is equals to 3x cubed plus 6x squared and plus 4x minus 5. Okay. This is question number 19 of the exercise 7a. This is the last question of this exercise. He says a curve has equation y is equals to 3x cubed plus 6x squared plus 4x minus 5. Show that the gradient is never negative. We have to show that the dy by dx value will be never negative. Okay, so we will derivate it. Dy by dx is equals to 3 into 3 into x squared plus 6 into 2 into x raised to power 1 plus 4 minus 0. So you see I have derivated it. So dy by dx is equals to, this is 9x square plus this is 12x plus 4. Okay, so we have to show that this never intersect with the it never comes below that x-axis. Okay, so let me think that, okay, let's make it equals to 0. So it will be 36 and 36, 9 4s are 36 and 12 3s are, so we cannot find any. Okay, apply quadratic formula, or you can say, you see, I don't remember that if you have studied that or not. B square minus 4ac. Find the discriminant of this thing. So that is 12 square minus 4 into 9 and into the c, that is 4. So that is 144 minus, what is this? 36 into 4. So 144 minus 24 to 12, 24. This answer is 0. So that means that if the discriminant of something is, this quadratic is equals to 0, this is discriminant b square minus 4ac. That means that it's a happy face. It touch the graph only at one point. It means it touched the x-axis, which is y equals to 0, only on one point. So it will not come, because it's happy face, if touch this, so it will not touch this x-axis at 2 points. So it's not coming below this y equals to 0 line. It will not come below the x-axis if you draw its graph. So the value of the 9x square plus 12x plus 4 will be never 0 from the graph we have shown this, because its discriminant is 0. So when the discriminant is 0, it touched the x-axis only at one point, and that's is. So I hope it's clear to you. We are done with the exercise 7a. If God willing, tomorrow we will do the next exercise, which is the 7b exercise. And you know, this is, I work for the students who need help in these concepts and in practice. Okay, so very brilliant students, I don't think that they need to work like this. Very brilliant students directly learn and they can practice from the past paper topical questions. So that's it for the today, and it's a good news that we have completed the exercise 7a of your syllabus. That this is, we are talking about differentiation. The first exercise was related with the derivatives and the and the gradient functions. So thank you very much everyone for taking our time and watching this video. So thank you. Have a good day. God bless you.